All right, we are live. Hello, everybody. Thanks for tuning in. Whether you're joining us from LinkedIn or X or Twitch or YouTube, we're happy to have you join us. Please feel free to engage in chat and drop some comments or questions. I'm excited today to have Miles join us from Moonrepo, who we got to know through Extism. And just as a reminder, this is an instance of our Exism community highlight stream. And we get to bring on just awesome folks from the community who are working on really cool projects, building companies, working on applications. And Miles is a great example of that. So welcome, Miles. Thanks for joining.
Thank you. Glad to be here.
Do you want to give maybe the audience here just a quick intro to you and kind of what you're working on? And
yeah, sure. So my name is Miles, of course. I founded a company called Moonrepo, which is a play on the word monorepo, because I built a tool called Moon, which is a monorepo management tool. It's kind of like a build system, a task runner, and has a bunch of extra features for managing monorepos, especially things around like code ownership and VCS integration. And I wanted to build it in Rust just for the speed. And on top of that, I built a second tool called Proto, which is just a multi-language version manager. I call it a toolchain, which is also used within Moon itself. It was originally part of Moon. It was pulled out into its own tool because people were like, this is cool. Let's use it separately. So I have these two tools, and the whole goal of Moonrepo is to just provide developer tools that just solve a problem space I feel like hasn't been solved very well yet, and I just want to provide a great developer experience.
Awesome. Well, great call. Writing it in Rust seems to be all the rage these days.
Yeah, it's pretty fun.
I'm curious why like monorepo specifically kind of came to mind. Have you had experience in the past managing monorepos where builds were challenging, and maybe you could shed a little light on how the tool kind of came to be?
Yeah, so I've worked in this industry a very long time, but for the last maybe 5+ years, I've been working on like developer tools teams at certain companies. And a lot of my job was like, how do we scale this repo? How do we make builds fast? How do we make CI fast? How do we stop linting from over linting or testing from over testing? So, over time, I kind of just like gained a bunch of domain knowledge in this area. And there's some tools out there right now. I wasn't particularly impressed with any of them. You have like Bazel, which I think works if you have a very complicated extreme case, or you have like C or C++ where you need to do like compilation and linking and all this stuff, and Bazel really helps with that. But a lot of monorepos are not that. They're just like JavaScript or Python or Ruby or just these like web-based languages that don't have good monorepo support. So the goal for Moon was to like, hey, let's build a multi-language monorepo tool that does a lot of deep integration with the language and just solves X, Y, and Z problems. And I think one of the main features that separates Moon from other competitors in this space is that it is multi-language, and we do like deep integration with these tools. So you could have like a Ruby task depend on a JavaScript task that depends on like a Go task, and you kind of can create this whole graph of how all these things work together and try and solve them all together instead of each language having its own tool to do only things that are like Go specific or JavaScript specific, So yeah, multi-language is like the end goal. Like, let's make this super simple for anybody who has a monorepo of multiple tools or languages.
That's awesome. I mean, I from personal experience, have been deep into like the make world, where my make file then shells out to a bunch of different little like Ruby environments or JavaScript or Python. And it's kind of nice to have one consistent view of how to actually transact across the whole repo. And I think the coupling with the like download capabilities of Proto is really nice too, because then you're not maybe going as far as like Nix or a full kind of Docker environment, but I kind of get the best of both worlds. I get to install all the tools I need as dependencies, and then use those tools and leverage them in the kind of build pipeline for the monorepo. So I think it's a great idea, and love that you're working on this, because it's certainly not, I think I agree, it's certainly not like a solved problem very widely.
No.
So I'm glad to see some progress being made here.
Yeah, it's pretty great.
So I'm curious how you found Extism.
Oh no, I think we lost Steve. I can keep talking though, because I think he was asking how I found Extism. And so honestly, I just found it through Google. Is he back? I'll keep talking. So while I was building these tools, I wanted a plugin system. So I've done a lot of JavaScript work, TypeScript, Node.js, whatever you want to call it. And their developer tools are heavy on plugin systems. And doing a plugin system in Rust is actually very complicated because of its dynamic and linking nature. So you can't do runtime-based plugins. You can do build time plugins, which kind of defeats the purpose because then the users can't actually add plugins ad hoc. So the only solution at the time was, hey, you need to use Wasm to have a plugin system. And I've heard the word Wasm before. I've never used it. I don't really know how it works. But I was like, okay, there's got to be something here. So just Googled a lot. I found Extism. And the selling point of Extism, there's actually a few points. Like one, the integration was super simple, and the way that the host code, which is like Proto or Moon are the host, and the guest code is the plugins. It's just simple function calls with input and output. Very simple. You don't have to do like weird classes or traits or weird connections between things. You just, hey, I want to call this function in the plugin, and the plugin returns an output. It's very simple. It's a contract that you can pass around. And the other selling point of Extism is it's multi-language. And what that means is, users who are, or like plugin authors who are creating their own plugins can write their plugins in whatever language they want. So they don't have to use Rust. They don't have to use JavaScript. They can write a Ruby plugin and then compile it to Wasm, or a Go plugin and compile it to Wasm. But then, Moon and Proto can use those plugins that are written in different languages and run them from our Rust runtime, which is like super nice. So it gives everyone the option to just build the plugins with the language they're familiar with. They just need to adhere to like the APIs and contracts that we provide, and everything just kind of works out of the box. So I've been using Extism for, I feel like it's over a year now. It's all good. I just kept rambling, and I think it worked.
I was a real pro. Just want to point out, this is, if you need someone to broadcast,
yeah, perfect.
Go back to it.
Yeah, I was gonna say like perfect timing for you to come back on, because I was like basically finishing my thought anyways. So I think it's a good segue into like the next question you had.
Timing is everything, and it sounds like we're still on track here. So thank you for just continuing. And I apologize, for some reason the connectivity just got
Sure.
wrecked. I was hoping we could also do a quick demo of Proto in action, just to kind of give the audience, some context around how you might use it, what you might be able to use it for, and then kind of maybe change into like how to increase the capabilities of Proto using plugins.
Sure. Let me share my screen. I have to share the whole screen, so it's going to do that recursive, scary stuff. Okay, can you see it? We good? I'm going to take that as a yes. So Proto and Moon are both command line tools, so there's nothing pretty to show unless we like dive into code. But Proto, as I mentioned before, it's a tool chain. It's a version manager for multiple tools. And a tool is anything from like a programming language, a dependency or package manager, a command line tool. Honestly, that's the big three. Some people, you can use it for whatever you want. If you have something that you want to have versioned and managed and kind of published, you can throw it in Proto. So for an example, I'll just show you some commands. So Proto has a lot of stuff. Right now it does a lot of things. But the big one is like, hey, I want to install a tool. So let's just install Node. I'll install the latest version. And as you can see, it's doing some stuff. In the background, it's doing a ton of things, and I'll kind of break it down once this is finished installing. So you can see I omitted the version, which just defaults to latest, and the latest version currently is 2250, and it has been installed here. So if I open up Finder on my computer, let me just make this bigger so you can all see. Go to the Proto folder, which is here, and then tools. So everything is organized in this tools folder. And right now I have a bunch of tools. Also have a bunch of test tools. That's how I test everything. So my Proto folder is kind of messy. But if you go to Node and open it up, I also have a lot of Node versions because I'm testing a bunch of stuff. So I installed 2250, and it installed it, it downloaded it, it unpacked it into this versioned path, and made it available. And if I also open up all these, you can see I have a bunch of versions of all these other tools. So it makes it like super nice to do things. And then I use shims, which are industry standard concept of shims. It just intercepts it and then pipes it to the correct binary according to the installation path and the version you want. And then we have this plugins folder. So this is all the downloaded plugins. So you can see there's a ton of things, and they're also using SHA hashes to uniquefy them because the plugins themselves also have versioning. So every time I need to patch something, for example, in the Yarn plugin, I'll just increment its patch and release a new Yarn version, and then it pulls it down here. And plugins, they have like a lifetime. I think right now it's 7 days. So every 7 days, I'll refresh it just to make sure we're using non-stale code. But one thing that separates Proto from other tools, compared to the fact that it's multi-language, there's not many multi-language tools there, is that it uses runtime version detection. And what that means is if I go into a project like a repo, say like repo A and repo B, and repo A has a like .nvmrc file for Node that pins it to like Node 18, and then repo B has like a package JSON with an engines field that wants like Node version greater than 21. You don't need to manually change what version you're using in Proto. Like, so you go to A, you're like, all right, I need to use Proto 18. I mean, you need to use Node 18. You don't need to do that. Proto will automatically determine what version you need, find it in your path, and use it. So as an example, I'll show you right here. So this is the Proto repository right now. Let me just add actually, let me show you it in action. So if I do Node version, right now it's defaulting to 2015 because that's what my like default global version is. And if I add logging here, you can actually see it's actually going through Proto, and there's a ton of stuff happening all within like a millisecond, honestly. But you can see here calling plugin function resolve version. So this is calling the resolve version function within the Node WASM plugin. And I'm like, all right, I'm passing the requirement of greater than 20, and then it returns 2015. So it did all its logic, returned its value. And then from there, I call some other plugin functions to actually determine where the executables are. And it finds it here. So this is the 2015 executable. And at the very end, I actually run the executable with the arguments passing the command line, which is here, and everything works. So I'll just add a quick nvmrc file. Let's change this to, that was the new one we installed, right? 2250. Okay, if I do it again, it now changes to 2250 because it detected this nvmrc file, and it now knows, okay, this project folder is using this version of Node, and it just uses it without you having to do anything. So if you like just changing directories, jumping around projects, switching tabs in your terminal, you never have to actually change the version of the tool you want. Proto will just detect it for you and run it for that exact version.
That's awesome.
Yeah, it's super nice. And you kind of mentioned earlier that like Nix is kind of a lot of work to get using. And Proto kind of sits in the middle, where if you want a development environment that's just like easy to use and easy to run, it's very nice. And one thing that Proto does, this is all just like configuration for testing. But if you have like a repo that's like, hey, I want Go, I want Node, I want Rust, I want whatever, you can add this Proto tools file to the root of the repo, and you can just add some versions here like this, 121, and let's do like npm 10. So that's just like telling Proto itself and also developers of this repo, like, hey, these are the versions of these tools we want. These are the versions of these tools that are going to be used. So now Moon will actually use these. So let me change this to 18. Let me delete this. And if I rerun this again, it should now show an 18 version. So yeah, so now it's using 18.19.1.
That's all.
Run it again. It's super fast. Like there's some, some slowdowns here and there where it has to like refresh the cache or download some files. But like the more you just run Proto, the faster it gets.
It's amazing. Just a couple quick comments on this, because I think it's worth calling out. Like, first of all, like the speed is incredible. I think we've all used tools like version managers that are mucking up with shell settings and configurations and loading profiles and things like that for every different application. This is like the fastest I've ever seen one of these tools work. So I love that. Looking through the trace log is really interesting too, to be able to kind of see what the tool is doing and seeing how much work it's actually doing for you in such little time. I love the idea of like the kind of shim feature where you're keeping the environment clean and like you're allowing the user to really put what they need in there, handling multiple different versions at the same time without having to do all these switching of versions back and forth based on, okay, what project am I in here? I think the tool just kind of handles that for you. And then the fact that you support like the NVMRC and you'll find, the project specific configuration just like meets a developer or team where they are already and lets the tool kind of fit right into their workflow. It does what you expect, like, which is, a very nice, unappreciated feature sometimes of these kind of dev tools.
Yeah, the reason this came about, and I'm sure everyone has dealt with this before, is when I was working on these developer tools teams, we had to provide support basically for all developers in the company. And a lot of the time, users would come to us and be like, hey, this command isn't working correctly, but it works on like this other developer's machine. And, we'll spend an hour diving into it. And it turns out they're just like using a Node version or some version of some tool that's like 3 majors out of date compared to what everyone else is using. And we just like wasted an hour of our time. And I ran into that all the time because people will just like, install something with Homebrew and then just forget about it forever and never change it. With Proto, I'm just like, I want to eliminate all those kind of scenarios as much as possible and just make things just work underneath the hood. So that's kind of where this came from. And I have like some other ideas in the future to also like make this a lot more easier to use.
The version management or misconfiguration is like always the root of a problem. If you can first just check, like, are you even using the right version of the tool?
It's always my first question now.
By the way, I can say this with experience, but open source maintainers love you, by the way, because of all the testing you do of multiple versions, like managed at the same time. So like we'd have an old version of Extism and something didn't work the way you expected it, and then you have a great, repro report for us. So seeing all those, npm versions and node versions and everything in your test directory is probably like the holy grail of, an awesome open source user.
I should probably clean that up. It's probably taking up a lot of space in my
Yeah, disk is cheap, whatever. Yeah. Hey, I wanted to also highlight some of the work that you've done to make integrating Extism really easy and then using Extism from a plugin developer's perspective, particularly in the work at the PDK layer. And for those who don't know, in Extism, a PDK is our term for kind of like a library that helps you write a plugin that fits the plugin into the host environment within where it runs. And Miles has done, I think, a better job than I've ever seen anybody do, including some of our own stuff, in making this like a really nice experience for a third-party plugin developer to build something. So I was curious if maybe you wanted to show a plugin and leveraging some of the libraries you've created.
Yeah, there's a lot of pieces here, so I'll try and make it brief. To give some context, so Moon and Proto both use plugins. Proto has one type of plugin, while Moon has two types of plugins. So I have three types of plugins to support. And in the future, there might be more. So I kind of needed, some abstractions that I can share across all three, so I'm not rewriting the same thing over and over again. So I created a bunch of stuff, and right now it's called Warpgate. So there's three pieces right now. Warpgate core isn't actually the plugin. This is run on the host side. So it manages the Extism plugin instance, adds some caching, provides host functions, like common host functions that I know I'm going to be reusing through all three types of plugins. So I'll quickly go over these. So I have a few things here. The first one's called like host log. This is just, if you never used Wasm, if you log in a Wasm plugin, it doesn't actually bubble up to like your console and terminal. It kind of just goes into like some stream somewhere, and then the host needs to like manage it. So I added this host log function where you can just call it and it will show up in the terminal, because sometimes these plugins are like, oh, hey, this has been installed in this location. And it's a lot easier for the plugin to send that message instead of sending it to the host, and the host need to determine how to actually display this message. So I have this function. I have an exec command function, which is actually very important. Sometimes, especially for Proto, they need to run commands on the host machine, like say like make commands just to like do some install or setup. So I have an exec command here that has a bunch of stuff around it for safety and virtual path management. Envar, getting a setting, you can't do that through Wasm either because it's kind of a sandbox. So I have some host functions around that. And a big thing that I've created is called virtual paths. So with WASI, which is like the Wasm, I don't know, what would you call that? Feature of Wasm that gives you file system access. It's a sandbox, so you don't have full access to the host machine. You only have access to the paths that the hosts whitelist for you. And I call these virtual paths because it maps like a fake path to a real path. For example, I'll just do it here. So a virtual path might be called just /proto. But this actually maps to like your home.proto folder. So in the Wasm plugin, all they have to do is just like write a file to /proto/ whatever, and it just gets mapped to this path on the host machine. So I have a lot of functionality around virtual paths and reading and writing them and converting to real paths and a lot of stuff. So there's a lot of things going on here. But these are like the main host functions that I know all the plugins are going to use. And then all the three other types of plugins might have their own unique host functions just unique to them.
Very cool. One quick question. Would you kind of consider this to be like maybe the custom standard library that you provide your plugins with that give them richer features that are particularly related to the behavior of Proto?
I would say yes. I'm trying to keep it generic. So there's anything in Warpgate is not Moon or Proto specific. Like I don't try and hard code anything in there. So it is kind of generic. So if other people want to use it, they can use it.
Gotcha.
But I am trying to like create these primitives that I know most people might use or will need at some point in the future. Because I definitely need them.
So I think the first one in your list is like a great example.
If you're using WASI, you're going to need this kind of stuff. If you're doing non-WASI plugins, then it's very simple. You're just like, I'm giving you an input and I want an output, and you're just doing some compute, and it's easy. But yeah, once you get WASI and you get operating system and file system and other things involved in Wasm, then it gets a little bit complicated, and you need these abstractions to handle it.
Totally. Speaking of those abstractions, maybe what does one look like from the plugin perspective's view to kind of like call into using one of these functions?
Yeah, let's see. So I have this tools repo. This is where all the official Wasm plugins are. So I officially manage like the Bun, DNO, Go, Node, nodes, package managers, Python, and Rust. So this right here, I believe this is the Node one. So yeah, this is the Node WASM plugin. And I'll just quickly go through it top to bottom. So I'm using this host function macro provided by Extism itself, which basically is like, okay, I'm going to use this host macro using the exec command, which I just talked about. So you need to, like, when you're using host functions, you need to register them in your Rust code, as seen here. And then all these other plugin function annotated methods are the actual plugin functions that are visible from the host machine. So I have one called register tool. That's kind of a required function. It lets you know, like, hey, this is actually a proto tool, because they could just give me some random WASM file and be like, okay, this is actually a proto plugin, but it's not actually a proto plugin. So I have this register tool that verifies, like, hey, this is a proto plugin, and this is the name of it, this is the language, and some other metadata. There's a ton of stuff here you can customize. And then all these other functions are basically optional. So this one's like, okay, where can I detect the version of the tool that I need to run? So the automatic runtime stuff I was showing you earlier, this is part of it. So it's like, okay, I can get the version from these 3 files, and let's ignore everything in node modules, because I don't want to pull in package JSONs accidentally. And then once we have those files, the host machine will scan the file system, and if it finds one, then it calls the parse version file function, which, you know, does all its magic. It reads package JSON, or it reads version files, does its thing, parses the version. So this is another thing I didn't talk about, but I had to write my whole like version parsing spec to handle versions across all tools, because all tools aren't actually Semver. They might have different variations. I had to build my own thing to manage them all, which makes it super nice in Rust, because everything's very like nominal strict type. And then like another one just for like loading the versions that are available. This one does a HTTP call to Node's distribution URL. Some of them just load Git tags. Those are like the 2 most common way of getting versions. And then this is like resolving the version. This really only matters if they pass like aliases or partial versions. So yeah, if they pass the alias latest, I need to actually figure out what latest is. And then some other things around architecture. Because as mentioned before, WASM has no context into the host machine, or like process information, or operating system information. So I have to personally, from the host runtime, pass it into the WASM plugin. So I have all these like host, architecture, and OS enums and data that I pass around. And then here's like a function for, okay, how do I actually download this language? Most languages are pre-built, which are just like zip or tar archives that I can download to a temporary directory, which is all this. It kind of maps out what the file, not the file, but the HTTP URLs are. And then the host machine will download it and unpack it. And then once it unpacks, it calls this function, which is like, okay, I've installed this tool into the tools directory. I've unpacked the zip archive, but like, where are the actual binaries that are executable within that install directory? Because all these tools do it different. It might be in a bin folder, it might be in the root, it might be like nested 3 levels deep for some reason. So I actually have to write a function to find all that information. So that's what this is doing. And then I also have like hook kind of related functions. So this is a post install hook that runs after you install the tool. And in this case, it will automatically install npm with Node, because Node comes bundled with npm. I mean, npm comes bundled with Node most of the time. So this kind of mimics that functionality. And like, that's pretty much it for like the WASM plugin.
That's awesome. That's like, I mean, it's a very sophisticated plugin. There's a lot going on in there, but the code's super readable. And like, you know, I think one of the unappreciated elements of WebAssembly from a like plugin systems perspective is that like it's the same plugin that runs across all those different architectures. So when you do all those switches inside of your plugin, because you need to detect, well, which version of my dependency am I going to download from the plugin? The benefit of WASM is that the plugin gets to stay the same code regardless of where you're landing it. So like if a proto user on Windows or a proto user on Mac using an ARM or an Intel chip, like doesn't really matter. The WASM's going to run there the same way. So like,
Yep.
I've written plugin systems where we had to shell out to an executable, and the executable is very specific for the architecture on which it runs. So you got to make sure that the right executable is installed for the Windows user versus the Linux user. And with this, it feels like you can just kind of ignore that whole class of concerns because the plugin is going to run independent of the architecture that the tool runs on,
Exactly.
which I think is just super, super cool.
Yeah, and back to your question earlier, like, okay, show an example of this integrating with like the utilities that Warpgate provides. So here's a good example is like Git host environment. This is actually provided by Warpgate. You can see here, it comes from the Warpgate PDK. And if I go back to the Warpgate PDK, go to the functions. So there's more functions here. So here's like load Git tags. I do all the hard, heavy lifting for you. So if you're writing a plugin and you just want to load the tags to figure out what versions you are, you can just do this. So there's a ton of functions here for you to use. And like, yeah, Git host environment, I do all the heavy lifting. I do the Rust typing for you and what values are available. So like this data is just super easy to use and you can just consume it.
That's great. Feels like some of that could be like factored out, and we should make these more reusable for other plugin authors or people building plugin systems to take advantage of, because like this is hard stuff, and it's not obvious how to get this stuff with WebAssembly in particular. So yeah,
I've done a lot of iteration, a lot of way changes, a lot of I think some of these plugins are like on version like 45, just to constantly change the APIs. But they've been pretty stable the last few months. So I think I'm almost there to getting everything where it needs to be.
That's awesome. Well, great work on all this. We are up at time here. I do want to just ask if there's anything you'd like to share in terms of like community engagement, if people can help out on anything, or you're looking for any kind of contributors in particular, and then just kind of ways to follow the project.
Yeah, I mean, I'm always open to contributions. I actually started a bounty system recently that's been super effective.
Cool.
Yeah, I'd say the biggest thing is I would love it if you just use Proto and Moon, of course. A lot of the ideas for these tools are basically just my own ideas, and sometimes I think they're going to work great, and in reality, they don't actually work out so great. And I would like to get that feedback earlier rather than later, because Proto isn't an official V1 yet. It's still a V0. And I'm waiting to kind of hit that stability mark before I flag it to a V1. So just have people use it. Let me know your feedback. If there's like some rough areas or some of the workflows or nomenclature don't really make sense, just let me know. I'm pretty humble. I don't get mad if you don't like something. So just let me know. And I'm totally cool just like completely changing some of these features, because I've done multiple times already. So there's been a few users of Proto since the beginning that have given me a lot of feedback, and I've completely changed how things work based on their feedback. And it's actually been good listening to that kind of feedback. So
that's great.
Just throw it my way, usually in the Discord.
Awesome. Well, we'll throw a link to the Discord in the notes on all these videos when they're hosted. Thank you so much for joining us today, Miles. This is incredible. Thank you for being an awesome member of the community. Go check out Moonrepo. Use it for all your monorepos. Check out Proto to install your dependencies. Great stuff. The tools work amazingly well, and
thank you.
Appreciate everything you're doing. So thank you again for joining, everybody. Tune in next time. We'll have another stream on Thursday next week, excuse me. Yeah, just looking forward to continuing to chat and work together, Miles. So thanks again. See everybody later on.
Awesome. Have a good one, everybody.